Hi boys and girls, this is lesson 5.5, adding tenths and hundredths. Make sure you get that written in your notebook with today's date, and when you have that, come on back. Okay, so here's a question for you. Alex made a poster with 100 paper clips for the 100th day of school celebration. 2/10 of the paper clips were gold, 45 hundredths of the paper clips were silver. The rest were other colors. Write a number model with an unknown to represent the fraction of the paper clips on Alex's poster that are silver or gold. Okay, so to think that problem through, we want to ask ourselves a few questions. First, what is the whole in this number story? So remember, we could show the whole by doing our whole box. Right now, we don't know. We'd have to fill it in after reading it carefully, and we do know the whole would be the 100 paper clips. Okay? Second, do the fractions in the number story refer to the same whole? Yes, they refer to the same because it's talking about 100 paper clips. That's the whole. So if you look at this number story, or this number model right here, it looks different than the ones we've done before. So what's different about it? Think about that. Hopefully you notice it's the first problem where the fractions were divided into different numbers of equal parts, meaning we now have different denominators. So unlike 1/3 plus 1/3 equals 2/3, that's pretty straightforward. I'm putting this piece that looks just like this piece together. I can do that easily. In this problem, however, we've got tenths and hundredths equaling our unknown, or clips. You could have chosen any letter, right? Okay, so let's think, well, what are we going to do with that? So since we know that in order to add fractions, they must refer to the same whole, we know that, do we also think that they need to have equal parts or the same denominator to be added? Does it have to be straightforward like the 1/3 plus 1/3 equals 2/3? Hopefully you'd say yes. Yes, fractions do have to have the same denominators to be added, just like I couldn't add apples and oranges together and say I have X amount of, which thing would I call it? There isn't a way to do that. I have to have my fractions with the same denominators in order to be added. So, in this lesson, we'll learn strategies for adding fractions with unlike denominators of 10 and 100. So now, let's look back at the original problem. How do you think we could rename the fractions in our original problem, 2/10 plus 45 hundredths, so that the fractions are divided into same size parts, or have the same denominator? That means the same thing, right? Divided into same size parts means have the same denominator. Hopefully you understand that. Alright, so write yourself some notes, think this problem through, jot down how you think you could solve that. When you have that done, come on back. So, there's a variety of ways you could have solved this. Here's 3 possibilities of what you might have said. Let's go over them. Even if you didn't say it, it's good for you to have this practice and to try and make yourself think through the other options that you could have said. Okay? So stay with me here. So let's look at this first one. So I could have changed the 2/10 to an equivalent fraction with the denominator of 100 by multiplying the numerator and denominator by 10, because whatever I do to the bottom, I have to do to the top. So if I want this to be 100, which I do in order to add it to the 45 hundredths, I could do 10 times 10. But if I do that, I've got to follow the rule. I hear you in my head, Audrey. Whatever you do to the bottom, you have to do to the top. Yep, there you are. Okay, so now both fractions would have a denominator of 100, so I could add them. I could do simple addition across like we have done when we already had common denominators. That's what all this is representing to you. So it could be 65 hundredths, 20 hundredths plus 45 hundredths equals 65 hundredths. Right there. Okay, that's one option. If you came up with that one, awesome. Here's another. We could have done a visual fraction model using base 10 blocks. So there's my 2/10ths filled in. Here's my 45 hundredths filled in. If I put them all together, I'm going to have 65 hundredths. So in essence, doing this step converted this for me, right? Because now I'm in the hundredths here. I could have thought about the whole display of 100 paper clips. If 2/10ths are gold, 20 of the paper clips are gold. That's what that's telling me. And if 45 hundredths of the whole are silver, then 45 paper clips are silver. 20 plus 45 equals 65 gold or silver paper clips. That's 65 out of the 100. And remember, the bar in the middle of a fraction, so let's just do this basic fraction for you here. Remember, this bar here says out of. That's the other way I can word that. So I could call this 1/2, no question, but I can also say 1 out of 2. That's what we're doing here. 65 out of 100. So there's 3 different ways that come to mind immediately for me that you could have done this. You may have done it yet another way. As long as you were able to get both of the numbers to have the same denominator of 100, you'd be right. And your answer should have ended up being 65 hundredths. Let's do some more practice with this. Write down these problems. Give them a try. I will tell you on this one that has a mixture of them in it, I would set it up for myself looking like a traditional addition problem, writing out beside the values to help myself. Keep that in mind. And then there's something special about this one. See if you can figure that out. I will talk about it on the next slide. Give it a go first. When you're ready, come on back. All right, so here's some answers here. I would have changed the 6/10ths into 60 hundredths because I would do times 10. 10 times 10 is 100. Whatever I do to the bottom, I have to do to the top. Therefore, 6 times 10 gives me 60 hundredths plus 3 hundredths equals 63 hundredths, or 63 out of 100. Great. 5/10ths would become 50 hundredths using that same method. 50 hundredths plus 41 hundredths equals 91 hundredths. Totally true. Then on this one I told you I would have lined it up like this, so I gave you that as how I would have solved it myself. 2/10ths equals 20 hundredths. I've still got the 9 hundredths. 15/10ths, yes, it is an improper fraction. That's okay. I can still multiply the bottom and the top by 10 to get 150 hundredths. And then the 31 hundredths carries over. If I add these together, I know I'm going to have hundredths on the bottom. Add the tops together, I'm going to get 210. 210 out of 100, right? That's definitely improper fraction. So I could make that into a mixed number. And my mixed number, I could say it's 2 and 10 hundredths, or 2 and 1/10. When I have a number like this, 10 hundredths, I could reduce them both by 10 to get 1/10. We'll talk a little bit more about that in just a minute here. And then this one, 7/10ths plus 10 hundredths. So I could have done it the same way I've done all of these. 70 hundredths plus 10 hundredths equals 80 hundredths. Or I could have kept the 7/10ths and turned my 10 hundredths into 1/10. Then I'd have 7/10ths plus 1/10 equals 8/10. Why can I do that? Think about that. Jot down a note as to why you think this is a possibility. What makes this special? Okay, here's the note that you want to make sure that you understand. Whenever there's a numerator, which is a multiple of 10, a numerator, the top number, numerator, multiple of 10, with a denominator of 100, that fraction can always be expressed as a fraction with 10 as the denominator. Because I could divide both by 10, right? Just like I can multiply the top and the bottom both by the same thing to still have an equivalent fraction, I can also divide the top and the bottom both by the same thing and have an equivalent fraction. So that's what I did here. So this 10 hundredths becomes 1/10. 10 divided by 10 is 1. 100 divided by 10 is 10. That's what else I could have done there. Okay, hopefully you feel pretty good about these. Let's go on. So now let's just compare this to what we've been working on recently, which are the mixed numbers, and make sure that we have strategies in order to solve these as well. So here's an example problem for us. So I'm adding 2 and 1/10 plus 3 and 25 hundredths. Why don't you pause the video, solve that whatever way you'd like, and then come back and take a look at the ways that I'm going to talk about. So you could have done the problem several ways. You might have decomposed the mixed numbers into sums of whole numbers. So I could take my 2 plus my 3 to equal 5. And then my fractions, I could convert the 1/10 to 10 hundredths. And then add that to the 25 hundredths. 10 plus 25 equals 35 hundredths. So my total answer is 5 and 35 hundredths. Notice I couldn't convert my 25 hundredths down because 25 is not a multiple of 10. So I can't make this the tenths. I have to make the tenths hundredths. Alright, so I could have done that, or I could have done this method. I could make each of these into these improper fractions and add them that way. So 2 and 10 hundredths would become, let's see, so for each one of these wholes, each one would be 100. So 200 plus the 10 gives me 210 hundredths. This 300, each of those whole numbers are worth 100, so that's 3 times 100, right? 100 plus 100 plus 100 is 300, plus this 25, 325 hundredths. When I add these together, I get 535 hundredths, which if I put it back in mixed number form is 5 and 35 hundredths. So this method may seem a little more cumbersome to you, but I will tell you, this method you want to make sure you understand. You will use this for problems where this is not quite so easy as you get into upper math. So make sure you have a little bit of a feel for this. We can definitely talk about it more when you come to the lesson. All right, you get to go practice now. Page 164 in your math journal. Show yourself and me your level of understanding. When you're done, come back and check your answers. Please correct those in pen so that you know things that you need more help with and I know things that you need more help with. That's how I can help you the best in the lesson. All right, so pause it. Come back when you're done. And here you go. Here are those answers. Well, these are sample equations. Yours might not be exactly this, but hopefully they're pretty close. Please correct yours. Circle anything that you got wrong or just make it really obvious so we can talk about it when I take a look at your book. All right, thanks for watching.